In this class, at first, I'm taking one relation, and that relation is in between the phase difference as well as the time period. Phase difference as well as the time period. So, how come we consider that? Phase difference, nothing but here we used to represent delta phi. Delta phi is equal to 2 pi by capital T into delta small t, delta capital T. This is the relation between the phase difference as well as the change in time period. Delta phi represents the phase difference. Delta t represents the change in time period. Okay, here capital T represents the time period. This is the one relation. And one more relation is a relation between the phase difference and the path difference. Delta phi is equal to 2 pi by lambda into delta x. 2 pi by lambda into delta x. Here delta x is the path difference, delta phi is the phase difference, and lambda is the wavelength of the particular wave. Okay, so these two formulae gives the concept as for one particular change in time period, what is the phase difference of the particular wave? What is the path? If you know the path difference, if you know the path difference between the two, then we'll get the phase difference of the particular two waves or two particles. Okay, now, and here I'm taking one example. And in the problem, they used to give two wave equations. Two simple harmonic motions are represented by y1 is equal to one problem. This is 10 sine of 4 pi t plus pi by 4. This is the displacement of one wave, and another wave is y2 is equal to 5 sine 4 pi t plus root 3 cos 4 pi t. This is another wave. So two simple harmonic motions are represented by y1 is equal to 10 sine of 4 pi t plus pi by 4, and y2 is equal to 5 sine 4 pi t plus root 3 cos 4 pi t. Calculate the ratio of their amplitudes. A1 is the amplitude of one wave. A2 is the amplitude of another wave. We need to calculate the ratio of these two. Okay, now see in this case at first we need to we need to take the equation. We need to take the equation of these two waves. How come? Listen. First y1 is equal to 10 sine of 4 pi t plus pi by 4. This is as it is. I had equation 1. Equation 2. The equation 2 is a little bit different when you compare with the first equation. Okay, so now we need to convert the second equation also in the form of the first equation. So for that purpose, here I am taking the concept it as y2 is equal to y2. I need to change the second equation, no? So consider y2. y2 is equal to the numerator denominator nothing but into 2. 5 2s are 10 into 2, and inside if I write here 2, inside the bracket I am taking 1 by 2. So if you multiply this term and this term, 2 get be cancelled, again you will get the 5, no change in the value. So 2 into 1 by 2 sine 4 pi t. If you write for one thing, then the value will be changed. If you write for both the things, here also I am taking that 1 by 2 root 3 cos 4 pi t. It means if you multiply this term 1 by 2 sine 4 pi t with 5 into 2, then 2 get cancelled, again you will get 5 inside sine 4 pi t. 1 by 2 into 2, again if you multiply, then 2 cancelled, again you will get the root 3 cos 4 pi t. So y2 is equal to 5 2s are, what's the value? 10. This I am writing like this: 1 by 2 sine 4 pi t plus 1 by 2 into root 3. I am taking it as root 3 by 2. 1 by 2 into root 3, I am taking it as root 3 by 2 cos 4 pi t, cos 4 pi t. Now y2 is equal to 10, 1 by 2. Sin, this is sin A cos B plus cos A sin B. So this I'm writing in the form of cos. Cos. Cos in for what angle we will get 1 by 2 in cos? Cos 60 degree. So cos pi by 3. Cos pi by 3 sin 4 pi t plus this I'm writing sin 60 degree. Root 3 by 2 is sin 60. Sin 60 means sin pi by 3 cos 4 pi t. Now y2 is equal to 10 cos A sin B plus sin A cos B. This is A and this is B. This is A and this is B. Cos A sin B plus sin A cos B. That is nothing but sin of A plus B. Sin of A. A is nothing but pi by 3. B is nothing but 4 pi t. 4 pi t. Now, this term I am rearranging as y2 is equal to 10 sine of a plus b or b plus a, both are same, 4 pi t plus pi by 3. This is the second equation. Just check the first equation as well as the second equation. First equation is y1 is equal to 10 sine 4 pi t plus pi by 4. 4 pi t sine of 4 pi t plus pi by 4. What is the trigonometric function here? Sine. Now here, so you see the second equation, y2 is equal to 10 sine of 4 pi t plus pi by 3, second equation. What is the trigonometric function here? Sine. Both cases we have the sine only. So now we are ready to take the answer, right? So now amplitude, ratio of amplitudes a1 by a2. Compare this equation. Y1 is equal to a1 sine of omega t plus phi 1. A1, A represents the amplitude. In the place of amplitude, what is the value here? 10. So now A1, I am taking it as 10 by Y2 is equal to A2 sine omega 2t or omega t plus phi 2. Omega t plus phi 2. Okay. Now here, what is the value in the place of A2? A2 consisting of 10. So 10 by 10, that is equal to 1. It means what? The ratio of amplitudes A1 is to A2 is equal to what's the value? 1 is to 1. 1 is to 1. Like this, we can solve the problem. In this, you need to remember two things. The first thing is nothing but first observe, that is wave the equations of the particles. Y1 is equal to one equation 10 sine of 4 pi t plus pi by 4, but y2 is equal to not like that, that is in the different way. So we need to adjust, we need to convert the y2 equation also in the form of the first equation. For that purpose, here I consider numerator and denominator multiplied with 2. The numerator 2 as it is I considered, the denominator 2 1 by 2, denominator 2 nothing but what's the value? 1 by 2, denominator 2 means 1 by 2, 1 by 2 send into the bracket. So it means 1 by 2 sine 4 pi t plus 1 by 2 root 3 cos 4 pi t. The next step is 1 by 2. Here 1 by 2 into root 3, what's the value? Root 3 by 2. 1 by 2, I'm writing it as cos 60. Cos 60 means cos pi by 3. Plus here this is sine 60, sine pi by 3. Cos A sine B plus sine A cos B is nothing but sine of A plus B. Sine of A means pi by 3, B means 4 pi t. Here you got the sine, and first equation also you got the sine. Both the trigonometric functions are same. Now we are ready to take the answer from this solution. So here the second factor is, first factor is observe the equations. Second factor is now observe the trigonometric functions in the both the equations. In one equation sine, another equation cos is present. Again we need to convert. Both the trigonometric functions should be same. In both the equations sine function will be present. In both the equations cos functions will be present. Otherwise, if one equation is sine, another equation is cos, that's not a way to do the problem. Okay. So now here at the time for taking the numerical or for doing the numerical, you need to take the caution, and that is both the trigonometric functions must be same, either sine or cos. Are you getting? Okay. Next one is here. I'm taking another problem. Another problem. The displacement of a particle executing periodic motion is given by. So one displacement of particle is given, y is equal to 4 cos square t by 2, 4 cos square t by 2 sine of 1000 t, 4 cos square t by 2 sine of 1000 t, sine of 1000 t. This is the equation. We need to calculate, find the independent constituent a simple harmonic motions. Find the independent constituent simple harmonic motions. It means in this equation, how many particles are there and how many particles are vibrating with the simple harmonic motions. How many terms of simple harmonic equations are present in this equation, that we need to calculate. Find the independent constituent simple harmonic motions. The meaning of that is we need to calculate how many terms are there in this particular equation. Just observe carefully. And here we have one important thing. For this I am taking one formula. Cos 2 theta is equal to 2 cos square theta, 2 cos square theta minus 1. Cos 2 theta is equal to, what is the formula? 2 cos square theta minus 1. Then 2 cos square theta is equal to minus 1, take this side, that became as plus 1. So 1 plus cos 2 theta. 1 plus cos 2 theta. Okay. So now here at first I am taking the concept it as y is equal to and here 4 cos square t by 2, 4 cos square t by 2 sine of 1000 t, sine of 1000 t. This I am taking in the form of, in this cos square is present, here theta is present. Theta means t by 2 here. Theta means t by 2. So now at first I am taking the concept it as this, I am splitting this term. I am splitting this 2 into 2 cos square t by 2, 2 cos square t by 2, okay, sine of 1000 t, sine of 1000 t. Okay, now, and this I am taking it as like this, y is equal to 2 cos square t by 2, 2 cos square t by 2, 2 sine 1000 t, 2 sine 1000 t. Okay, so now in this I am taking the concept it as, listen carefully, and this 2 sine 1000 t as it is I am mentioning here, as it is I am mentioning 2 cos square t by 2. Instead of 2 cos square t by 2, I am taking it as in the form of 1 plus cos 2 theta. Y is equal to 1 plus cos 2. In the place of theta, what we have here? T by 2. T by 2. 2 sine 1000 t. Very simple. 2 cos square theta. 2 cos square theta. What we used to write it as? 1 plus cos 2 theta. 1 plus cos 2 theta. This is theta. Theta place lo emundi ikkada? What we have in the theta place? T by 2. So now 2 get cancelled. Then y is equal to 1 plus cos t 2 sine 1000 t. Now multiply with every term. 1 into 2 sine 1000 t, 2 sine 1000 t, 2 sine 1000 t plus cos t into 2 sine 1000 t. General multiplication. 2 sine 1000 t cos t. Okay. So now here, and this I am taking it as y is equal to 2 sine 1000 t, and this we are taking it as a 2 sine c cos d. 2 sin c cos d. This 1000 t is taken as c, cos t is taken as d. Okay. So now this is again I am taking one more formula. In the trigonometric you have one formula, sin c plus sin d. Sin c plus sin d is equal to 2 sin c plus d by 2 cos c minus d by 2. This is the formula. This is the formula. 2 sin c plus sin d is equal to, what's the formula? 2 sin c plus d by 2 cos c minus d by 2. Okay. So now here I'm taking it as in the form of the same. Here 2 as it is sin. This is nothing but c plus d by 2. C plus d by 2. Sin c plus d by 2. In the place of c plus d by 2, what's the value? Just observe carefully. Very, very important problem this is. In the place of c plus d by 2, what is the value? 1000 t. 1000 t. Now, here at the same time, this is c minus d by 2. C minus d by 2. In the place of c minus d by 2, what's the value? T. Sin of c plus d by 2, 2 sin c plus d by 2. In the place of c plus d by 2, in the place of c plus d by 2, what's the value? 1000 t. In the place of c minus d by 2, what's the value? T. So it means what? C plus d by 2 is equal to 1000 t. C minus d by 2 is equal to t. Okay. Now that implies c plus d is equal to cross multiplication 2 into 1000 t, 2000 t. C minus d is equal to cross multiplication 2t. Now I am solving these two equations. Plus d minus d. I am adding this. Plus d minus d. These two can be cancelled. So now c plus c, 2c. 2000t plus 2t. If you add 2002t, you will get. Now c is equal to 2002t by 2. Then c is equal to 2 ones are 20, 20, 2 ones t. Concentrate properly. C is equal to 1001 t. 1001 t. Okay. C value we got here 1001 t. Right? I need to calculate the d value. Now substitute in any equation. This I am taking it as equation 1 from 1. From 1. What's the value? C minus d. C minus d is equal to 2t. In the place of c, I am substituting as 1001 t minus d is equal to 2t. Is equal to 2t. Send the minus d to that side, that became plus d, plus 2t this side, minus 2t. 1001 t minus 2t, and that is equal to, here you will get it as 999 t. This is d. What is the c value? 1001 t. What is the d value? 999 t. Substitute these two values in this equation. Plus, in the place of 2 sin c plus d by 2, in the place of 2 sin c plus d by 2 cos c minus d by 2, this entire value is 2 sin c plus d by 2 cos c minus d by 2. Finally, what we got here? What we got? What is the formula? Sin c plus sin d. What is the c value? 1001 t. So I am writing it here, sin of 1001 t plus sin d. What is the d value here? What is the d value? 999 t. So now here sin 999 t. So now a sin omega t, a sin omega t, a sin omega t. Where is the a here? 1. A represents amplitude 1. Here also a represents what? Amplitude 1. So a sin omega t, a sin omega t, a sin omega t. In this form, generally the wave equation is present, and that's why in this equation y is equal to 4 cos square t by 2 sin 1000 t, consisting of 3 independent terms: 2 sin 1000 t plus 1 sin 1001 into t plus 1 sin 999 into t. So if you pronunciate 1, or if you are not pronunciating 1, no problem. Simply we are taking that 2 sin 1000 t plus sin 1001 into t plus sin 999 t, consisting of Thereby, this equation consisting of three independent simple harmonic motions. Three independent simple harmonic motions. Like this, we can solve this problem. Now, I'm taking the further important concept, simple pendulum. Simple pendulum. So as you know well, this is one rigid support, one light inextensible string. At the free end of the light inextensible string, one bob is attached. Then this arrangement is known as simple pendulum. Okay. Now, this is the center of gravity of the bob. From point of suspension to the center of gravity of the bob is known as length of the pendulum. From point of suspension to the center of gravity of the bob is known as length of the pendulum. The length of the pendulum is L. Okay. Now, the time period of this pendulum is T is equal to 2 pi root over L by Z. Time period of the pendulum T is equal to 2 pi root over L by G. L by Z. Okay. Now, what is the meaning of time period? So in the last video also, I already have done. What is the time period? Time period is nothing but time taken by the pendulum or by the particle or by the body. So here pendulum, time taken by the pendulum to complete one oscillation is known as time period. T is equal to 2 pi root over L by Z. The general formula in this case is time period is equal to T is equal to 2 pi root over displacement by acceleration due to gravity. Simply we call it as acceleration. T is equal to 2 pi root over displacement by acceleration. Okay. Now, see in this case, we have different applications. And those different applications are at first here we are taking the concept it as square on both sides. This equation T square 2 pi whole square 4 pi square root L by G whole square nothing but L by Z. If you square on both sides this equation, then you will get this. And then here from this I am taking the concept as the concept of seconds pendulum. Seconds pendulum. What is the seconds pendulum? Whose time period is equal to 2 seconds. Whose time period is equal to 2 seconds. Then that pendulum is known as seconds pendulum. It means it clearly indicating that the time period of the seconds pendulum is 2 seconds. So it means T square 2 square. 2 square means 4 pi square L by G. 4 get cancelled. 4 get cancelled. Okay. Now here 1 is equal to pi square. Pi square is approximately equal to 10 L by G. G is nothing but acceleration due to gravity, that is equal to either 9.8 or 10. Now here I'm taking 10. So Z value and 10 value get cancelled. L is equal to 1 meter or 100 centimeter. This is the length of the seconds pendulum. This is the length of the seconds pendulum. So the time period of the seconds pendulum is 2 seconds. The length of the seconds pendulum is either 1 meter or 100 centimeters. Either 1 meter or 100 centimeters. Okay. Now, the pendulum is arranged in the lift. The pendulum is arranged in the lift. So like this is the lift. A pendulum is arranged in the lift like this. The pendulum is moving upwards with the acceleration a. The pendulum is moving upwards with the acceleration a. And then what is the time period of this pendulum? When the pendulum is moving upwards with the acceleration a, what is the time period? So here at every point the existence of acceleration due to gravity, as you know that. Okay, and now the particularly this body is moving upwards with some acceleration, that is a. In this case, the effective acceleration G effective is equal to G plus A. Remember this? When the body is moving upwards with some acceleration, then the G effective, nothing but on this body, two accelerations are working. One is the gravity, the other one is the acceleration of the body. Then the body is moving upwards. Then G effective is equal to, what's the formula? G plus A. Then with that, time period T is equal to 2 pi root over, what's the formula? L by Z. Instead of G here, I'm writing G effective. That is equal to 2 pi root over L by G plus A. T is equal to 2 pi root over L by G plus A. Now, and this is the lift, and this is the pendulum. Now the pendulum is moving downwards with the acceleration A. Pendulum is moving downwards with the acceleration A. Then what about the G effective? Just now I said to you that when the lift is moving upwards, Z plus A. When the lift is moving downwards, Z minus A. G minus A. Now, what is the time period? T is equal to 2 pi root over L by G effective, and that is equal to 2 pi root over L by G minus A. L by G minus A. Getting? Now, another application. And this is a car. The car is moving with A acceleration. This is the car. Car is moving with A acceleration. Now inside the car, to the roof, one pendulum is fixed. One pendulum is fixed. Okay, now see, one pendulum is fixed like this. Okay, so on this pendulum, I'm using one word, one pseudo force can act in this direction. Due to that, if the vehicle is moving with A acceleration, this bob is moving in the opposite direction. Nothing but pendulum is moving in the opposite direction with the same acceleration. At every point, the gravity acting vertically downwards. Now the resultant is nothing but G effective. Z effective. Okay. Now G effective is equal to, according to parallelogram law of vectors, A square plus G square, and angle is 90 degree. No need to write the third term in the parallelogram law of vectors equation. Now G effective is equal to, what's the value? Root over A square plus G square. Now what about the time period? T is equal to 2 pi root over L by G effective. What is the G effective? Again root over A square plus G square. And this is the time period of the equation. Time period of the pendulum when the vehicle is moving in the forward direction, then what is the time period of the pendulum which we arranged inside the vehicle is nothing but T is equal to 2 pi root over L by root over A square plus G square. Okay, focus on that. Next, another application. The same concept, T is equal to 2 pi root over L by again root over G square plus A square, G square plus A square, and this value here, after taking some calculations, this also equal to 2 pi root over L by G secant theta, G secant theta, and this also can be taken as 1 by secant theta is equal to cos theta. So 2 pi root over L cos theta by G also we used to write like this. L cos theta by G. So if the in the vehicle, if the pendulum is arranged, if the vehicle is moving with A acceleration, then the time period of the pendulum is t equal to 2 pi root over L by root over G square plus A square, or equal to 2 pi root over L by G secant theta. 1 by secant theta is equal to cos theta. So that also written as like this, 2 pi root over L cos theta by G. Okay, another application, another one. See, in this case, now the vehicle is nothing but car. Now the car is moving in the curved path. Now the car is moving in the curved path. So car is moving in the curved path with a constant speed v, with a constant speed v. In that case, how come we consider the time period of the pendulum? Okay, so now this is a curved path, and in this curved path, it is moving with constant speed, and that constant speed is v, and the radius of that curved path is nothing but r. Radius of the curved path is nothing but r. Now, in the vehicle, one pendulum is arranged. Now, what is the time period of the pendulum? When the car is moving in the curved path with constant speed, with constant speed, and that is nothing but what? T is equal to 2 pi root over L by. Generally, in the denominator, we used to get what? We used to get the acceleration, right? So root over L by G square plus A square. Here that is acceleration. Acceleration is nothing but V square by R. V square by R, A square whole square. A square is nothing but that is whole square. Like this, we can consider the formula when we consider the part of this. Here that A square, A is nothing but centripetal acceleration. That centripetal acceleration is nothing but V square by R. So in the problem, T equal to 2 pi root over L by G square plus A square. A square is nothing but we need to arrange the formula as V square by R, again whole square. Okay, like this we can consider the formula when the vehicle is moving in the curved path of radius small r and moving with the constant speed v, then the time period of the pendulum which we arranged inside the vehicle is t is equal to 2 pi root over L by G square plus V square by R whole square. Okay, another one. So another application, in the air we have done the experiment, that is nothing but time period is t is equal to 2 pi root over L by G. In the air, the time period of the pendulum is t is equal to 2 pi root over L by Z. Okay, now when the pendulum is taken into the fluid, nothing but liquid. Now we are doing the experiment in the liquid. Okay, at that moment, what is the time period of the pendulum? So in this case, once the body is immersed in the fluid, then one force can be present, that is called buoyancy force. Due to the effect of buoyancy force, what happens here? The weight can be changed. The weight can be changed. Now, Z, T is equal to 2 pi root over, here I am taking it as T dash. After immersed in the liquid, the time period is T dash. 2 pi root over L by G into 1 minus dl by dB. 1 minus dl by dB. dl is nothing but density of the liquid. dB is nothing but density of the bob or density of the body which you immerse in the fluid. Okay, dl is the density of the liquid and dB is the density of the bob. Bob is nothing but that is a solid, and that's why density of the liquid by density of the solid. This formula also we are taking it as T dash is equal to 2 pi root over L by G into 1 minus 1 by rho. 1 minus 1 by rho. Okay. Now, here rho is nothing but specific gravity of the bob. Like this, we can consider the concept. Here T is equal to 2 pi root over L by Z, and that gives that time period of the pendulum in the air. When the pendulum is immersed in the liquid, then the time period is T dash. T dash is equal to 2 pi root over L by G into 1 minus dl by dB. dl is nothing but density of the liquid dB is nothing but density of the body. That formula we used to consider like this also. T dash is equal to 2 pi root over L by Z into 1 minus 1 by rho. Here rho is nothing but specific gravity of the bob. Specific gravity is nothing but density of the body by density of the liquid. Specific gravity rho is equal to, what's the formula? Rho is equal to density of the body by density of the liquid. So if you write density of the body by density of the liquid, the fraction can be reversed. Again, you will get the same formula. Like this, we can consider some of the applications related to the simple pendulum. Now, one more application related to the time period. Now, all this is the topic which includes the gravitation part. Okay, so whereas in the gravitation, if you go some height, the acceleration due to gravity gradually decreases. If you go some depth, the acceleration due to gravity again decreases, right? So now here, what is the relation between the time period and the acceleration due to gravity? The formula itself is very clear. That is, T is equal to 2 pi root over L by Z. Then T is inversely proportional to Z, nothing but root Z. If the gravity increases, capital T decreases, time period decreases. Gravity increases, time period decreases. Gravity decreases, time period increases. Why? Because both are having inversely. Now, so here, if the pendulum, simple pendulum, is taken to some height, at that time, how the time period relates, altitude. And the concept is, after taking multiple uh, data related to the same concept, finally we can take this formula. Delta T by T is equal to H by R. Delta T, change in time period. Capital T, initial time period when on the surface of the earth. Capital T is nothing but time period of the pendulum on the surface of the earth. H is the height for which the pendulum is taken. R is the radius of the earth. Okay, delta T is equal to H by R into T. Okay, so now if you are taking H height, how much loss takes place? In the time period? This delta T is nothing but that gives either loss or gain. If height increases, gravity decreases. Okay, so now here gravity decreases, time period increases, and time period increases, nothing but we will get loss of time period. So now the time loss per day can be taken as time loss per day. Time loss per day is equal to, how come we consider that? And that is delta T is equal to H by R. Per day how many seconds? T, 86,400. Per day how many seconds? 86,400 seconds. Like this we can calculate that particular concept. Okay, in the same way, if you take into the depth, so what is the fraction of time period changes? This delta T by T represents the fraction of time period. That is equal to, how come we consider that? That is nothing but 1 by 2 into D by R. Just remember, related to the altitude, just H by R. Whereas in case of the depth, delta capital T by capital T is equal to 1 by 2 into D by R. So now here the time loss per day is equal to delta T is equal to cross multiplication 1 by 2 into D by R into capital T. 1 by 2 into D by R into capital T. Now delta T is equal to same. Per day how many seconds? 86,400 seconds. So delta T is equal to 1 by 2 into d by r into 86,400 seconds. Sometimes in the problem they used to ask percentage change in the time period. Then delta T by T into 100. That is nothing but you will get here h by r into 100. Delta T by T into 100. That is equal to h by r into 100. And here also delta T by T into 100. That is equal to 1 by 2 into d by r into 100. You will get it as. Okay. Now I'm taking another topic related to the loaded spring. Loaded spring. Loaded spring. Okay. Now, well, how come we can explain the topic of loaded spring? Already you know this. Already you know this. This is one rigid support. One spring is considered like this. Now I attach the body to this free end of the spring. Then the spring is like this. If I attach any body at the free end of the spring, then this can be extended to some length and comes to the equilibrium. I attach a body of mass m. Then it extends. The spring extension takes place and comes to the equilibrium. That equilibrium here I am taking it as O. That is the mean position O. That is the mean position O. Okay. Now the spring consisting of one constant that is called as force constant or spring constant. Spring constant or force constant. That is K. That is K. Okay. So now here when the spring is moving downwards, nothing but the body is moving downwards, then the displacement is upwards. Listen carefully. Listen carefully. So now here force is acting downwards. If you release that, then it moves upwards. It means one force can be generated within the spring. That force is known as restoring force. If the body is displaced downwards, the spring moves upwards. So it means force is downwards, the displacement is in the opposite direction. So that's why here restoring force is generated within the spring. That restoring force is nothing but, otherwise this is the displacement of the body and it is the force acting in the spring. Force acting in the spring. Okay. Displacement of the body is in the downward direction. The restoring force which is produced in the spring is in upward direction. So F is equal to or F proportional to Y. If the displacement increases, the restoring force generated within the spring also increases, but in the opposite direction, and that's why minus Y. Force and displacement both are in the opposite direction. Then remove the proportionality and keep a constant. That constant is K. That constant is K. Okay. Now here that K is nothing but that K is equal to m omega square. That K is equal to what's the value? M omega square. Omega square is equal to K by M. Then omega is equal to what's the value? Root over K by M. Root over K by M. Here K itself is called as proportionality constant, itself is called as spring constant or force constant. Now T is equal to what's the value? 2 pi by omega. Then T is equal to 2 pi by omega goes to numerator, and that is nothing but root over M by K. This is the time period of the loaded spring. T is equal to 2 pi root over M by K. Whereas in the case of time period of the simple pendulum, T is equal to 2 pi root over L by Z. T is equal to 2 pi root over L by C. And whereas in the case of loaded spring, time period T is equal to what's the formula? 2 pi root over M by K. So here, if you are taking M by K, this formula, M is nothing but mass of the body. Here we are not considered the mass of the spring. You are not considered the mass of the spring. If the mass of the spring also taken into consideration, if the mass of the spring also taken into consideration, then what is the formula? If mass of spring also considered, then what is the time period? T is equal to 2 pi root over m plus m by 3 by k. Here small m is the mass of the body, capital M is the mass of the spring. What is the capital M here? Capital M is equal to mass of spring. If mass of spring is neglected, this is the formula. T is equal to 2 pi root over m by k. If mass of the spring is considered, then the formula of the time period of the loaded spring is T is equal to 2 pi root over small m plus capital M by 3 by k. Here small m represents the mass of the body which you attach to at the free end of the spring, and capital M is the mass of the spring. Okay, and now the springs are connected in series as well as springs are connected in parallel. If the springs are connected in series combination of springs, series combination of springs. Okay, so now if the springs are connected in series, then how come we consider this part like this? This is one spring having the spring constant is K1. Another spring here we attach it like this. The springs are connected one to another continuously, then that combination is known as a series combination. K1 is the force constant or spring constant of the first spring. K2 is the force constant or spring constant of the second spring. At the free end of the spring here we connected one mass, that is small m. Okay, so thereby here the weight is acting vertically downwards, thereby force is acting downwards. Then elongation in the first spring is y1, the elongation in the second spring is y2. The total elongation or extension is y is equal to, what's the formula? Y1 plus y2. The total extension is y is equal to, what's the formula? Y1 plus y2. Okay, same force is applied on both the springs, first spring as well as second spring, and that's why here we are taking that generally, you know, one formula, F is equal to ky minus, you forget about the minus gives the direction between the force and the displacement of the spring. Okay, F is equal to ky. Okay, y is equal to F by k. Y is equal to F by k. Now in the place of this is the resultant. After adding two values, you will get the resultant y, and that's why here I'm taking that F by, I'm writing it as ks. Ks means what? Ks means what? Force constant in case of series combination, that is equal to y1. Y1 is nothing but F by k1. Same force is applied on first spring as well as second spring, plus same force is adding F by k2. Take out the F as common and cancel both sides. Then 1 by ks is equal to, what's the formula? 1 by k1 plus 1 by k2. 1 by ks is equal to 1 by k1 plus 1 by k2. If the springs are connected in series combination, the effective force constant in the series combination is ks. So for calculating the ks in series combination, we used to take this formula, 1 by ks is equal to 1 by k1 plus 1 by k2. After calculating this, then ks is equal to, you will get this formula, k1 k2 by k1 plus k2. Ks is equal to k1 k2 by k1 plus k2. If only two springs are present in series combination, straight away take this formula, ks is equal to k1 k2 by k1 plus k2. Now more than two springs are present, then 1 by ks is equal to, how come we consider that, 1 by k1 plus 1 by k2 plus 1 by k3 plus and so on. Like this we need to take the formula. Getting? Okay. Now, and whereas in this case, in this case, how come we consider the time period? T is equal to 2 pi root over m by, for example, in the system, only two springs are present. Only two springs are present. What is the K effective? This itself is the K effective. Ks itself is the K effective. Now the formula became as 2 pi root over m by what is the K effective? That is Ks. Why? Because the two springs are in series combination. So use this formula K1 K2 by K1 plus K2. So K1 K2 by K1 plus K2, that is in the denominator. So the fraction can be reversed. Then that became as K1 plus K2. That became as K1 plus K2. Like this, we can calculate the time period of the uh, two springs which are in series combination. Okay, got it? And next, parallel combination. Parallel combination of springs. So in this case, we used to take rigid support. This is one spring having the force constant is K1, and this is another spring having the force constant is K2, and these two are connected like this. This is one lightweight rod, and to this one body is attached like this. That is M. That is M. Okay, like this is present. In this case, when like this are arranged, then this is called parallel combination. In this parallel combination, all the first ends, this is first end, first end. First ends are attached to one end. The second ends of the springs are connected to the another end. This combination is known as parallel combination. Okay, so now here forces are not same. Forces are not same. On this spring, some force is acting. On this spring, some force is acting. So that is here F effective is equal to the force acting on the first spring is F1. The force acting on the second spring is F2. But the extensions are same here. But the extensions in the springs are same. The extension in the first spring is Y. The extension in the second spring also Y. So F effective is equal to, how come you consider that? K effective into Y is equal to F1 K1 into Y, F2 K2 into Y. Take out the Y as common and cancel. K effective is equal to, what's the formula? K1 plus K2. This K effective itself we call it as a Kp is equal to K1 plus K2. So the effective force constant in the parallel combination is Kp is equal to K1 plus K2. K1 plus K2. Now time period. Time period T is equal to 2 pi root over m by k effective. Then T is equal to 2 pi root over m by k effective is nothing but what's the value? K1 plus K2. K1 plus K2. That itself is nothing but effective force constant in parallel combination. Okay. So if number of springs are attached like that, then what about the value? Number of springs. Kp is equal to K1 plus K2 plus K3 plus and so on plus Kn. So if number of springs are connected in parallel combination, this is the formula for effective force constant. If only two springs are connected, then this is the formula for effective force constant. Okay. Okay. Another concept here. One concept is present related to the reduced mass. Reduced mass. It means here masses are connected in parallel combination. It means how come? This is one body of mass m1, another body of mass m2, and these two masses are connected in the spring like this. These two masses are connected by using the spring. With only one spring, two masses are connected. Two masses are connected. The force constant of the spring is K. In this case, we need to take the reduced mass. What we need to consider? Reduced mass. Reduced mass is equal to 1 by nothing but m1 m2 by m1 plus m2. This is the value of reduced mass. When two bodies are connected only with one spring, then we need to consider the reduced mass. That formula is m1 m2 by m1 plus m2. Now what is the time period? T is equal to 2 pi root over m by k. Here m is nothing but m reduced by k. Only one spring is present. Then 2 pi root over m reduced m1 m2 by m1 plus m2 into, in the denominator k is present, that k as it is we consider. This is the formula of time period when both the bodies are connected only with one spring. By the introduction of the reduced mass, we can calculate the time period of the system.